Hello, and welcome to Chapter 4. Today, we're going to be talking about making comparisons. We're going to be performing cross tabulations with the XTP function, mean comparisons with the compmeans function, and particularly visualizing comparisons with plot mean C and box plots with SVY box plot function. So remember, anytime we start a session of R, we want to run our library function, bring up the poli-sci data, run that. So right now we're going to be talking about mosaic plots and how to build them with the XTP function. So as you can see in line 3 here, and on page 62 and 63 in the book, the formula for XTP plots is you want to put in your dataset first. So we're going to be using NES, our dependent variable, and our independent variable. And again, don't ever forget the weights. So we're going to run our function here. And there we go. So remember, anytime we start a session of R, we want to run our library function, bring up the poli-sci data, run that. So right now we're going to be talking about mosaic plots and how to build them with the XTP function. So as you can see in line 3 here, and on page 62 and 63 in the book, the formula for XTP plots is you want to put in your dataset first. So we're going to be using NES, our dependent variable, and our independent variable. And again, don't ever forget the weights. So we're going to run our function here. And there we go. Okay, so now we want to create a line chart. And in order to create a line chart, our dependent variable needs to be numeric. So we're going to make our dependent variable the answer envir in environjobs. So what we want to do is we want to run this function in line 8, which would create every answer that is envir into a numeric function. So the number 1 will be coded for anyone who responded with this answer here. And then we want to check our work using a frequency function. So this should be just envir. Well, this is the answers from our previous plot here. And we can check it again, full data. There we go. So because we want to graph percentage instead of proportions, we have to multiply the indicator by 100 before we can use the plot means function. So we're going to run this function in line 13, NES envir equals 100 times NES envir. Okay, and then we're going to run our plot means C function from page 66. And make sure you're following all of these specific codes. You can see right here that it's a little different than usual. For the X label, we're going to use party identification, and for the Y label, we're going to use percent pro environment. And for our main function, we're going to use percentage favoring environment over jobs, and then you can use this /n as a line break in your title by party identification. So we're just going to run that. Great. So we're now on page 66. I'm talking about a mean comparison analysis. So with comp means, you want the independent variable is a factor and the dependent variable is numeric. So for this example, we're interested in the dependent variable being attitudes towards Hillary Clinton, and the independent variable is partisanship. So the hypothesis is that in a comparison of individuals, Democrats will have more favorable attitudes toward Clinton than will Republicans. So we're going to take our compmeans function here, and we're going to put in our NES dataset, and we're going to do ft underscore h Clinton, and then we're going to use party ID for our independent variable, and then don't forget your weights, and we're going to turn off the plot here. So as you can see down here, this gives us the mean value of our feeling temperature on Hillary Clinton according to party ID. So the mean for a strong Democrat is 83, whereas the mean for a strong Republican is 32, proving the hypothesis. And for a line chart, if we were interested, we could take the function here and put it into our plot means like we did on the last example. So we're on page 67 here, and we're going to put in for our X label party identification, Y label ratings of Hillary Clinton, and for our main title we're going to do ratings of Hillary Clinton \n to cut down a line by party identification, and that should give us a chart over here. There we go. It gives us the exact mean per section of party ID, and you can see it's a somewhat smooth line graph going down. So a box plot is a little different because it describes a numeric variable by graphing a 5-number summary: the minimum, lower quartile, median, upper quartile, and maximum. And the box plot is also used to reveal outliers. So if we're going to use the same variable, we're going to use the function svy box plot, should fill in for you once you start typing it, and we're going to do ft for feeling thermometer underscore h Clinton, and then we're going to do PID underscore x for party ID, and then we're going to use NESD. NESD with the end after it is for, or with the D at the end of it is for design. And then we're going to add all outliers equals true. So it shows any outliers, and it'll give us that. And on the bottom of page 68, it shows you how to label the X label and Y-axis also, and it also shows you how to add color to make it light gray or any other color you could choose, and how to make the box widths proportional using the var width function. Strip charts are useful for displaying case-level information, which makes them particularly helpful with smaller data sets like states or world. So suppose we're interested in comparing levels of unionization in different regions of the US. We would run a compmeans function, obtaining the mean of states union 10, which is the percentage of the workforce belonging to a union, by states region, which is the region of the country. And if we put plot f, it should not give us a plot, but it will give us the mean of the regions in the area. So the Northeast and the West seem to have the strongest mean. So we can create a basic strip chart with this function here, strip chart, and then you take your two variables and the data set, and you can graph it. And it's a little confusing here. So on page 70 at the top, it gives you a way to make it a little clearer, so you can label the x-axis, the y-axis, the title. You can make it vertical, which is a little easier to read, and you can add a jitter, which kind of it overlaps them less so you can see them better. Something like that. It's much clearer, much easier to see, but you can also get a better idea of clusters like in the south or in the west. Yeah, so that was the end of chapter 4. Stay tuned for chapter 5. Thanks.